Hi students, good morning all. Today we are going to discuss a topic, atom molecules. Okay, so let us look into that. So atom and molecule, you have a clear idea. I think I am just revising or brushing it up. Okay, so let us see what is molecule. Molecule means what? So many molecule we have learned, different type of molecule we have learned, right? So there are different type of molecules like O2, CO2, H2, all these are molecules. So what is a molecule? Okay, molecule we know, we can see this is a molecule we can. So what is the definition of a molecule? It is the smallest particle of an element or a compound. Okay, so that is capable of independent existence and has all the properties of that compound. Okay, so I am going to give you a glass of water. Okay, if you take a glass of water, inside that what is there? Only one pure water I have given you. Pure water means only water molecule should be there. So the smallest particle, if you are taking from here, which is having independent existence, which is having a stability, that is H2O molecule. If you take any part from here, this is filled with H2O, H2O, H2O molecule. So the smallest particle which is present here is H2O. So that is a molecule that is having independent existence. And if this H2O is all the properties of this water. All the properties of this water, each and every molecule of water is having. Right, that is called a molecule. So what is a molecule? Smallest particle of an element or a compound that is capable of independent existence and has all the properties of that compound. Understand? That is called a molecule. Okay. Now, what is, let us see, what is the difference between an element and a compound? We have already learned that in this chapter, this is coming again. So you must know that. So element means what? Element means, from the name itself, it consists of only one type of particle. Okay. So if I am taking a copper rod, okay, it consists of only one type of particle inside. The full is comprising of copper. So that is called an element. Okay. But when you take a compound, it consists of more than one type of element like H2O. Okay, two elements are there. So carbon dioxide, two elements are there. Okay, so more than one type. So elements are extremely basic and individually consist of one kind of atom. That is important. It consists of only one type of atom. So compounds are elements that are Compounds are not elements. It consists of more than one elements that are intermingled with one another. Yes, elements that are intermingled with the one another. Okay, so then we are getting the compound. So hydrogen and oxygen intermingled, then you got a compound. Clear? So an element, if you take an element and compound, an element we are representing, copper is an element, Cu, oxygen is an element, O. So we are using a symbol to represent an element, and to represent a compound, what we are getting, what we are using to represent a compound, a formula. Water, carbon dioxide, formula of carbon dioxide, in this way we will use. Okay. And if you cut copper, you're not going to get anything. Copper we cannot cut, okay? But if you cut chemically water, you'll get hydrogen and oxygen. Understand? So we can chemically we can separate a compound, but we cannot do for an element separation, okay? So for an element can no longer be break down and can be broken through chemical reaction, right? In the case of compound. So if you see the atomic number 8, you can immediately understand that is oxygen. Okay. So from the, for an element, from the periodic table, we can identify very easily using the atomic number, which is that element. Okay. This from chemical bonds we are getting. What is chemical bond? You are going to learn in grade 10. Okay. So which type of bonding it is, based on that we are finding a compound. Okay. Yes. Now let us see the more detailed or more basic idea about element. Okay. So as far as element is considered, what we can write element is, we call sometime element as atom of an element, right? Atom of an element. Sometime we will call an element as molecule of an element. What is the difference? Molecule of an element. So atom of an element means oxygen. This is atom of an element. But if you represent O2, if it is combined with another atom, then it is called a molecule. If it is same type of atom, then it is molecule of an element. Otherwise, it become compound of a, molecule of a compound. Understand? So the same element it must be. So it is atom of an element, and this represents molecule of an element. Okay. Now next. Let us see what is the difference between pure substance and mixer. Pure substance means it consists of only one type of particles, right? So this element consists of only one kind of element, one kind of atom only. Element means only one kind of atom should be there, okay? So compound consists of more than one type of atom. Even then it is pure. If you take water, we can tell it is pure water if it consists of only water only inside, okay? But if you are putting some sugar, then it is impure. It consists of another compound, okay? So if it consists of only one type of compound only inside, then it is also pure. So element and compound is also pure, okay? Next. What is an atomicity? What does it indicate? It's very easy. How many atoms are in a molecule? We will count the atom present in a molecule. That is atomicity. Okay. Let us see some cases. Look at this table. Argon, helium. These two are called noble gases. Okay. They will never combine with anyone because they are stable already. Okay. So these are called monoatomic because only one atom is present. But when you are considering oxygen, how it will be? Oxygen means O2, right? Oxygen means O2. It consists of two atoms in the molecule. So it is diatomic, hydrogen diatomic, two atoms, nitrogen diatomic, two atoms, chlorine diatomic, two atoms. Okay. Phosphorus consists of four atoms inside that. So it is tetraatomic. Triatomic also you have an example. It is not given here. Triatomic means ozone. O3 is triatomic. And sulfur is S8. If more than 4 is coming, then it is called a polyatomic. All the metals are monoatomic. Okay. Na, Fe, Al, they are all monoatomic. Okay. What is atomicity? Very easy. What is atomicity? Atomicity is very easy. The number of atoms. Okay, now let us see what is this ratio. This is given in your textbook. Okay, don't be panic. It is very easy. Water means what? Water consists of hydrogen and oxygen, H2O. So if you are considering the elemental ratio or atomic ratio, they are in 2:1 ratio, right? 2 hydrogen and 1 oxygen. Okay. So if you take the mass ratio, hydrogen, the mass of hydrogen is 1. Since there are 2, 1 into 2. Okay, so hydrogen and oxygen. 2 for the mass of hydrogen become 2, and for oxygen, how much it is? 16. So when you take the ratio, it will cancel and you will get 1:8 ratio. That is what given here. Okay, they are in 1:8 ratio. Now ammonia. Nitrogen and hydrogen. So nitrogen and hydrogen we are taking. Nitrogen is 14. Hydrogen, how many are there? 3. So 3. So they are in 4:3 ratio. 14:3 ratio. And let us take carbon dioxide. Carbon and oxygen. Carbon is 12. Oxygen is what? 16. 16 into 2 because 2 oxygen is there. So 32. So when you cancel it, you will get how much? 3:8. Okay. 3 4s are 12s and 8 4s are 32. So 3:8. This is the ratio. That is what you are getting here. Okay, I think it's clear for you. Now next, let's see. Next thing. That is an ion. What do you indicate by an ion? An ion or is a group of atoms. It's a group or an atom carrying a charge. So ion, from this definition itself, you can understand two types of it. Monoatomic ion, and we can monoatomic ion, and we have polyatomic. So what is monoatomic? It consists of one atom, like aluminium 3+, calcium 2+. That is monoatomic. Polyatomic means that it consists of more than one atom carrying a charge. A group of atom carrying a charge is called a polyatomic ion. Okay? Yes. Now, next. This ion, we can again divide into two categories, cation and anion. What is the difference between a cation and anion? Cation means ion carrying a positive charge. Ion carrying a negative charge is called anion. So how it become aluminium become a cation? All the metals are usually cation and non-metals are usually anions. Okay, so how? Aluminium is actually leaving the electron. Okay, and whenever an atom is leaving electron, if it is leaving 3 electron, 3+. Whenever an atom is leaving electron, it will give positive charge. Whenever an atom, suppose oxygen is or chlorine is gaining 1 electron. Whenever an atom is getting electron, then it become minus. Okay, and yes. Next, we have to learn some ions and their charge, because next class I am going to teach you formula writing. So you have to understand what are the charge. Okay. So let's see that. Sodium, sodium, all these metals are having +1 oxidation state. Okay. +1 is the charge. And magnesium, calcium, strontium, nickel, iron, iron and copper 2+. Okay, aluminium and Fe 3+. Fe is having two, actually, two charges are there. Some cases it is +2, some cases it is +3. And -1 oxidation state is fluorine, chlorine, bromine, and iodine. Oxygen, sulfur, and selenium -2. And then nitrogen and phosphorus -2. This all you have to by heart it. Okay. And polyatomic ion also we discussed, right? So these are the example for polyatomic ion: ammonium, NH4+, acetate, CH3CO minus or C2H3O2 minus, carbonate, CO3 2 minus, phosphate, PO4 3 minus, hydroxide, OH minus, sulfate, SO4 2 minus, sulfide, SO3 2 minus. These all are examples, okay, of polyatomic ion. This all you have to learn also. So here one thing is very important, always you will make mistake. Nitride, nitride, IDE means without oxygen, N3 minus, okay, nitrogen. Nitrite is NO3 minus 1. Nitrite, 1 oxygen less, NO2 minus 1. Okay. Another thing you are making mistake is sulfide. Sulfide means S minus 2. Sulfite means SO3 minus 2. Sulfate means SO4 minus 2. Okay. Don't make mistake among these. Okay. This all for today. Next day we are going to learn a very interesting thing, formula writing. So bye for everyone.